This is a talk given to Yealm U3A in June 2020 about solar energy and talking about Yealm Community Energy's investment in 2 solar farms on behalf of the local community. So it's going to cover briefly the science behind solar energy and photovoltaics, and then describe these 2 community solar farms, explain how they connect to the grid, and a bit about what Yealm Community Energy is doing and how the income from these solar farms is supporting local projects. So to start with the solar energy spectrum, this is showing the energy that arrives at the outer atmosphere here on Earth and varies from the very short wavelength, high frequency UV end down to the longer wavelength, low frequency infrared side. So the visible spectrum is about 40% of the energy, 45% here, rather more energy in the infrared. The interesting part from solar energy is around the visible spectrum, where these photons have higher energy. And on a hot sunny day, sitting under a tree, you wonder, nice cool shade, what's happening to all that solar energy? And of course, it's being absorbed by the tree. Green is the reflection of the sunlight. Surprisingly, because the green part of the spectrum, it has the most overall energy in it. But the actual absorption of the photosynthesis is primarily the blue end and the red end, unless the high energy green part, which is maybe too much energy for the plants to absorb. And so what's going on? The photons from the sun striking the leaves, they knock electrons out of the water molecules in the leaves, which enable the carbon dioxide to combine with hydrogen and to produce, through biochemical process, sugars, which are chemical energy stored in the plant, and at the same time produce oxygen. So this is the basis of almost all life on Earth, requiring water, carbon dioxide, and sunlight. And of course, this has been going on for hundreds of millions of years, and that chemical energy has been stored underground over millions of years, and we've been busy digging it up recently to burn and even to use it to produce electricity, which is a very inefficient process because it takes well over 3 units of chemical energy to produce 1 unit of electricity in a power station by the time you've dug up the fuel, transported it, and so on. So photovoltaics, a process discovered in 1839 by a Frenchman called Edmond Becquerel from a very clever family. In fact, his son Henri got the Nobel Prize with Marie Curie for discovering radioactivity. But nothing much was done with this photovoltaic principle, although Einstein used it to describe what was going on with the photons and the interaction with the electrons in about 1905. But since the 50s, it was started to be used mostly based on silicon. There are other materials that can be used for satellites, powering satellites in space. And of course, since then, the prices have come right down, and it's now about the cheapest way of producing electricity. So what they consist of? They have very thin slices of crystals of silicon in 2 layers. The top one doped with phosphorus using phosphine gas at a very high temperature, and then the bottom one doped with boron. And this gives the ones doped with phosphorus extra electrons, and the ones with boron a shortage of electrons. so that when the photons release the electrons in the silicon, they will flow to the other side where there's a shortage and create a current, a direct current. And the energy used in this process is more or less the visible spectrum plus a bit of infrared, but most of the infrared just cannot have enough energy to produce electricity, but it just heats up the panels, which is actually a disadvantage because when the panels get hot, they're not as efficient. So on a cold, sunny day, you get more electricity than on a hot, still day. So the panels produce about 5 watts at about half a volt, and a typical panel has about 50 cells and produces about 1/4 kilowatt. In the solar farms, the one at Newton Downs, they're arranged in strings of 22, and 8 of those strings feed into each inverter, and the inverters are converting that direct current into alternating current so that it can be fed to the grid. So on the solar farm of 5 megawatts, that's about 1 million solar cells over 25 acres, and that 600 volts 400 volts alternating current is fed into 2 substations where it's converted into 33,000 volts to feed into the grid. Now we're lucky here in South Devon, we have very good annual solar radiation, which is about 1150 kilowatt hours per square meter, which is about 15 to 20% more than you would get in the Midlands, for example. This Newton Downs solar farm is in a dip in the hills here. It can't be seen from any road or footpath. And it's a small part of this Newton Downs farm. So it's feeding into this green line, which is 33,000 volts, which in turn supply the red lines, which are 11,000 volts, going round to the villages and farms and so on in the area. And it'll be producing way more energy than can be absorbed by these areas. So in the summer, midday, most of the energy is going up to the rest of the country through the national grid. The second solar farm is about 4 kilometers to the east at Creecombe, and it's about 50% bigger, 7.3 megawatts. And that's also feeding into the 33,000 volt line between Yampton and Holberton. This is just a map to show the Yealm area, these 5 parishes, and the 2 solar farms which Yealm Community Energy is in the process of buying. There's another commercial farm at Brixton, built a few years ago, which unfortunately really has no benefit to the local community. They paid for 18 kilowatts of panels onto the local school, but otherwise nothing else. Whereas these 2 solar farms are generating £35,000 a year to provide grants to local projects. Now, as I say, this electricity is going into the national grid. The black is the 400,000 volt line, which goes along the A38. Up here is Hinkley, and down here is the gas-fired power station at Langage. And when these were originally built, they were supplying Western Power Distribution to distribute, and it was a one-way system from the big power stations to the consumer. And nowadays it's much more complicated, and surprisingly the electricity system operator, which is part of the national grid, are now saying that they'll be able to take 100% low carbon energy, that's nuclear and renewables, by 2025. So over the last 10 years, the whole electricity supply industry has become much more complicated, and a lot of very clever people working out how, between them, Western Power Distribution, the distributors, and the national grid can balance all these different generating sources. And that requires a lot of data, so that a lot of data is supplied by the solar farms to the asset manager, in our case, a company called Bright Renewables, which is partly owned by Yealm Community Energy. And they're able to monitor exactly what's going on in the solar farm. So this is 3 days last August, sunny day with no clouds and a couple of slightly cloudy days. And over the year, you can see that over the 6 months of the summer, about 2/3 of the energy is produced and a lot less in the winter. And the UK is making huge progress towards zero carbon electricity. This is a day at the end of May 2020, and you can see the yellow here is solar in the daytime. The turquoise color is wind. Down the bottom is nuclear, very steady, can't be easily switched in and out. The orange is gas. The brown color here is biomass, which is a mixture of from biogas plants or from gas from municipal waste, or even burning wood in power stations. There's a very small amount of hydro there, the blue, and then there's imports. For example, shortly there'll be hydropower from Norway. We already get wind power from Ireland and from Holland and Belgium, and nuclear from France. And there's also storage, and its storage is increasing rapidly. So there are a lot of ways of balancing the grid without having to burn gas. And as I said, this requires a huge amount of data in order to manage this system. We're helping Western Power Distribution by monitoring the substation here at the Fairway, because they don't have data from it up till now. It's supplying the Fairway and Court Road and all the houses. And Western Power Distribution want to know what will happen when a lot of people start using electric vehicles or heat pumps. It's going to change. They don't know whether they're going to need to upgrade their substations. And we find that this was last year in July, that sometimes in the middle of the day, electricity was going in the opposite direction through the substation from what it was designed. Not just drawing electricity from the grid, but actually supplying the grid, even from the few photovoltaic systems. So overall, Yealm Community Energy is producing about 13.5 million kilowatt hours of electricity a year, which is enough to feed about 3,500 homes, about 85% of the homes in the 5 parishes over a year, and saving about 3.5 tons of CO2, 3,500 tons of CO2. Yealm Community Energy exists to invest in clean energy. So these 2 solar farms is just a start, we hope. And that is creating a community fund, at the moment £35,000 a year, in future quite a lot more, from the surpluses from the revenue from the sale of electricity. And that money is used to provide grants to local communities for a range of projects, partly to alleviate energy poverty, houses which are consuming more than 10% of the household income in energy, just in energy. Also, it's a great opportunity for educating children and adults on climate change, environmental issues, and, for example, providing opportunities to visit the solar farm and find out what it's all about, and also to promote biodiversity and sustainability for our community. So we're looking for a lot of projects in that sort of area. So that's it. Many thanks.